Hey guys, Nick here. Hey, and I kind of wanted to follow kind of the short that we did the other day, where I talked about your STEM toolbox and why a 3D printer like this one should be incorporated into that toolbox. Not just for STEM learning, but also for rapid prototyping, um, and some smaller type of things. For example, these type of printers can print many different filaments. For example, your Ender 3 here can print all your basic filaments: PLA, TPU, ABS if it's in an enclosure, ASA, and some other interesting filaments. If you upgrade the hod end on these things, you can actually start printing and have it in an enclosure, for that matter. You should be able to start printing like nylon and stuff like that. For example, without an enclosure, this filament right here, which is ABS, is extremely hard to print because of warping, because of the fact that it's not dry, and there's a magnitude of different things. There's a lot of people, within the YouTube community that actually covers printing with ABS, and we will do that. But the other thing you can do is you can print stuff like this in PLA, which is considerably cheaper, and have working prototypes and stuff like that. That stuff that you don't really not going to use for production, not that you're going to use for anything. I guess you could say major. It's nothing that's going to be weight bearing. Like, for example, ABS you can use for interior parts, you can use for logos, you can use for anything that is going to be at a temperature differential. Same thing with ASA. ASA is a harder, maybe harder, might be easier to print filament than ABS. However, ASA can be not acid washed, but it could be put into a container with acetone, and will actually vapor smoothing is what it's called. Sorry, you can actually use vapor smoothing to get rid of your layer lines using ASA. So, there's different ways and different things to think about, especially when you're really getting into that particular toolbox. I really do think that your affordable Ender 3 is probably going to be your best bet. And the reason why is the Ender 3 is easy to use. We did an assembly video on it on our Vulcanar Technology Solutions channel. We'll link that video to this video as well, so you guys go take a look at that. When we first got this thing, we did one for Ed. We also did my Ender 5, which I think is another great option. You saw some of the comments back and forth in the short where we were talking about the Bamboo Lab P1S. I think it's a great printer. I think the ASA is great. Not the ASA, but the AMU, better known as MMU if you're coming from a different world as far as different type of printers, which is multi-material U unit. That means that instead of having one roll, on the side of my printer, I will have a container that will hold multiple rolls of filament next to each other. If you are in the Voron world, they have a couple open source kits that you can use, along with the guys from Creality. Creality, I believe, is coming out with their MMU this year. I believe it's already out with a new K1 that they came out with. But I do think that these printers are extremely affordable. You can get into a Ender 3 Ender 3 Pro for under $100. Maybe a little over 100 in some places when you start talking about tax. Micro Center always tends to run a deal on the Ender 3 V2 Pros, and it is your basic printer. You're not going to be getting anything major, you're not going to get anything fancy. It is to learn the technology. It is definitely to learn and then upgrade. It's not something, if you want to keep with it, keep with it. You can upgrade these printers, they become the Legos of the 3D printer world. And a lot of people, they build parts for them, they have parts for them, they swap out a lot of things on them. They swap out the hot ends, they swap out a lot of the different parts and features of it. You know, they add linear rail to it, which are a better gliding system instead of using what is considered like wheels. As it is more accurate. The To give you an idea, the Ender 3 V2 will actually use, sorry, a linear a foot system. So it uses a different type of wheel. So that wheel will guide up and down the printer. And you actually see it on the hot end as well. That will use that to come across. Now, if you come over to the Ender over here, the Voron, sorry, my bad, over here, you can actually see that rail back there where the hot end sits. So wherever that hot end sits and moves back and forth, it's gliding. It's going to be gliding on, of rails of some sort. So what that means, sorry, is that it is a, linear rail type of system. Are they more accurate? Yeah. Are they easier to maintain? Well, that's to be determined. Some people love, linear rail, while some don't. Some find the wheel systems, easier to maintain because they are. You don't have to oil them. You don't have to grease them. You don't have to do anything with them. You kind of just let it go. But the thing is you may give up a little bit of accuracy, plus or minus a couple mils. But the good thing is all these machines can be changed out to run, different operating system Clipper. It can be also, most of them can be put on automated printing systems and stuff like that. So, you can actually turn them into a little mini print farm and stuff like that. So, it's like Octoprint, Octoprint, Octofarm. If you are running more than one, you can run Octofarm. And then you can log into one interface and you have one printer. You have, printer A, B, C, D, whatever. And then all of them are on one page. You can go in there and look at them. You can see what they're doing. A lot of times you start seeing that inside Clipper. However, that is, it's if you're running all your printers, you're running on Clipper. If you're not, and you're just running a Raspberry Pi with Octoprint and the original OS that is on, sorry y'all, on these printers, then you can easily, just kind of add Octoprint to it, add Octofarm, as an attachment, and then build out from there. You don't have to change anything out. You can easily take it and load it via thumb drive all day long that you want to. And then eventually you can go over to a system where you can log in from your PC and just hit the go button. That's kind of what we do. Everybody that I usually, work with as far as 3D printers go, everything is going to be, Clipperized. It's going to have the version of Clipper on there. Or the version of Clipper. And the reason is you can easily take your files from CAD and save them as STL, then immediately upload them into your slicer of choice. And it's really your slicer of choice. I love to recommend Super Slicer. That's what I use. However, you have many different variants of slicers for 3D printers, and I like to tell people that that is really up to their own preference. Um, and the reason is not everybody uses everything that's part of the slicer profiles. So, what I use is because of the Voron. However, if you're running an Ender, you can run the Creality software. If you're running any of the other bigger, print names and stuff like that, you can easily run, their slicers and stuff like that. You have the Prusa Research and their slicer, Prusa slicer. You can easily jump into that if you're running a Prusa. If you're running a Prusa, it's as easy as plug and play. And then most of those slicers give you the ability to send the print on your network to the printer. And so that's kind of like one to one. If you're really going to be adding a 3D printer to your workshop as a tool, I would highly recommend getting it on Clipper, getting it on Octoprint, just so you can get to it. Especially if your printer is not co-located to your PC, if it's out in the garage or if it's in a workshop where you're doing rapid prototyping or you're doing a learning set, then you may need to be able to fire it off from a distance. If you are doing a learning set with these things, I highly recommend that if you are in a school type environment, to have them in an enclosure, because of the fact that they do get hot and there's a chance that they could hurt people. But the thing is if you're smart about it, you have fun with it, you can easily learn it. And that thing is that kind of goes hand in hand with like 3D scanning and stuff like that, because now I can take the 3D scan, load it through the software that is from RevoPoint, break out the cloud set, load it into a CAD software that I enjoy, break it down, and then go ahead and upload to my software. Then I can go ahead and pin out what I need and then go from there. Now, speaking of CAD and stuff like that, if you're just getting started in CAD and stuff like that, think about Tinkercad. Tinkercad's free. Tinkercad is a free online, kid-friendly CAD system. Everybody can use it. You're not having to download Fusion 360, which is free for anybody to use, unless you have a license. But now it's free if you're not using it for business. If you're using it for business, then you have to pay a fee to it, for a licensing fee. Not all CAD software is free. You have FreeCAD, FreeSCAD, a couple others if you like to do a little bit of coding on top of that. So I highly recommend making sure that you have some sort of CAD software if you're interested in it. If you're not, just going to be downloading, CAD files or STL files for that matter, or STL files from like printables and stuff like that. And so if you are doing that, that's fine. But the thing is grow a little bit, have a little bit of fun with it, learn something new. And that's the reason why we have these things. It teaches everybody a new skill. It teaches people to have a little bit of fun with it and a little bit of learning. And that's what it's all about. It's about, taking this tool and throwing it into your toolbox or putting on top of your toolbox and then going from there. Because now you can turn around and build parts with a 3D printer that you've built in CAD. And now you can print them for just a couple dollars and try them on a vehicle, try them on a motorcycle, power sport, motorsport, anything you want to try it on. Make sure it fits before you take that CAD file and send it to a company to do it in metal, or before you even put it on a CNC machine and have to go through the process of doing CAD and CAM, routes to it, stuff like that. So, this type of stuff it's easy to get into. It's fun. It's affordable. One roll of PLA, 1.75 mil PLA, which is what the Ender takes, is going to cost you about $16. $16 to $21, somewhere around there. Thing of PLA, I just bought a roll of PLA for $18, and it's 2.2 pounds. It's 1 kilo, and with that, it'll last you a long time. For example, your nozzles, you can buy a pack of nozzles for these machines for, I think it's like $12, maybe a little bit more. The copper plated nozzles, and you don't have to change them out every so often. Make sure you guys do get a big jug of isopropyl alcohol 99 to be able to clean the beds and stuff like that, just because it's easier. You don't have to go out and spend a lot of money on these things. And I really wanted to clarify that from when I did the short, the YouTube short for that. Wanted to make sure you guys kind of knew what I was kind of talking about and kind of go a little bit more in depth and, have a little bit more fun with it, because, we're all going to try something new. Like, for example, you see the piston print, that I have here. I'm actually going to be reworking this a lot. Probably a little bit, after the new year or after the holidays, we'll be reworking this. I'm going to be working with my print temps and stuff like that. So you can kind of see in there, it's a little stringy. I'm just trying to focus. But inside the ring holes, you can kind of hear that. It's a little stringy. My temp was a little bit too high. So I'm going to, it came out absolutely gorgeous. Don't get me wrong. It came out, perfect. However, I'm not happy with it, because the one thing I want to be able to do is take a piston print like this and be able to build a jig that helps teach people how to do your piston rings. Because then you can take your measurements off of the piston top over here, and develop a cylinder sleeve set that will slide down inside the cylinder sleeve, mimicking a loading of a piston into an engine block. It's cheaper than, buying a motor. It's cheaper than buying pistons, especially if you're doing this in the classroom, or if you just kind of want to teach somebody, hey, this is how you do your compression rings, your oil rings, and stuff like that on a piston. So, then you can use the same exact tools to load it into the simulated engine block, and then, kind of go from there. Kind of teach people how that thing works. If you really wanted to, you could print, a rod, on it and actually build an entire working set to do a motor simulation, and it'd be cheaper than going out and buying a full motor. Because you only, would only be printing maybe a couple cylinders, and then you'd have to just develop the crank, for it to work. But, that's kind of some ideas, some stuff that we will be, working on ourselves. And then, stuff we'll be sharing with y'all, as we kind of go through this. Probably I'll bring you onto the computer whenever I do the modifications to this file, so we can actually take a look at it. Our goal is to start really printing some motorsport centric parts, so you guys can use them and stuff like that, because we will be taking the STL files when we're done with them and uploading them to the Vulcanar Motorsports website, and those will be available for download for free. We're not going to charge you for that. Never want to. I'd be happy if I can give a lot of stuff away for free. That's the goal. That's why we do this, because I think everybody should learn. Everybody should have fun. Everybody should get interested in motorsports. Everybody should get interested in, in STEM. And, our big goal eventually is to start doing, a vehicle build. So that's kind of what we're aiming for at the beginning of next year. We're going to start doing that to get ready for some events. Hot Rod Power Tour is one of them that we want to get ready for. And then, be able to, take that, vehicle to, different type of charity events and stuff like that, to try to inspire people to get into STEM, and also to show our appreciation for the motorsports community. So, I hope y'all, kind of learn something. I hope y'all are actually thinking about adding a 3D printer to your toolbox. So with that, I hope y'all have a good one. Thank you for everybody who tunes in, who watches, who comments, whatever. But also y'all, whoever, go out there and take a look at, the Tech at Lunch podcast, where we actually kind of go in depth, and I'll have more tech related, topics, and more in depth into a lot of the 3D printing topics and stuff like that. So y'all might find that interesting. However, with that, get out there, learn something, inspire somebody, and, show people that, one, motorsports isn't dead yet. It's not going anywhere. STEM is not dead yet. If anything, incorporate the A, which is STEAM. Bring in some arts and have some fun with it. We love our painters and stuff like that are, out there building and painting cars. Or even just, printing murals. Those guys are pretty awesome. So, go out there, have some fun, get people inspired, catch a race, and also, let us know what you're working on. So we hope to see you again, and y'all have a good one.